In this part, we're going to talk about inverse relations. So, in terms of this section, we're going to be talking about our x and y table. So, on the left, we have the xy table for the f of x function. On the right xy table, we have for the f to the negative 1 f of x, and this is a symbol for meaning that the inverse function. So, how would you tell if two tables are inverse to each other? If you closely look at the x and y values, meaning that if two functions are inverse to each other, then the x and y values are flip version of each other, or a reflection of each other. So, let's take a look at the first coordinate. So, notice how from f of x, our x and y values, negative 3 and negative 5, are flipped for f to the negative 1 of x, the inverse function. And then take a look at all the other coordinate points. So for f of x, 7, negative 2 is flipped, which is now negative 2, 7 for the inverse function. And then on the third, for f of x, it's 9, 1, 9, 1. When you flip it, it's going to be 1, 9 for the inverse function. So that's how you would know is when you look at the table and examine closely to the x and y values. If they are flipped version of each other, then they are inverse to each other. So therefore, f of x and f to the negative 1 of x are inverse to each other. So that's what you would basically determine if two functions are inverse to each other, is by closely looking at the xy. And let me talk about it. So when you flip, the x values of f of x are the y values of f negative 1 of x. The y values of f of x are now the x values of f to the negative 1 of x. So again, in order to determine if they're inverse to each other, is you flip it and see if they match. And it ties in closely when we talk about two inverse functions, and you would see that they are inverse graphically. Alright, so say we're looking at this example and determine if g of x and h of x are inverse to each other. So in order to determine that is if you flip either x and y values between each function and see if they're the mirror image of each other or the flip version of each other. So, just like I said before, if they are inverse of each other, then the x values are the y values of the other function, and the y values are the x value of the other function. So let's take a look at the y values. 1, negative 3, and negative 7. So they must be the same for the x values for the second function, which is 1, negative 3, and negative 7. Then let's take a look at the x values. They have to be the same for the y values of the second function. So negative 6 and 5, that's not the same. Even though that the second one is the same, we can also see that the third one is not the same. So if we closely examine each coordinate point, we notice that only the second one is the flip version of each other, while the first one and the third one are not. So if I were to flip this, negative 6, 1, this should be 1, negative 6. Or, if I were to flip 1, 5, then this should have been 5, 1, which in this case is not. So, even though we do have one that is the same, if within two relations, two xy tables, if there's one coordinate point that is not the flip version of each other, then the only thing we say is not inverse. So we would say not inverse. In the event when you're examining two relations, two xy tables and one corner point are not the flipped version of each other, so not inverse.